confusing. The concept of gravity becomes more complicated when you examine a complex system, like an elevator going up or going down. Going up. When the elevator is accelerating up, what happens to your weight? When it first starts to move, you feel as though you're being pushed down a little. You can feel the elevator's acceleration. The elevator is pushing you up, so according to Newton's third law, you push down against the floor. It makes you feel a bit heavier for a moment. A scale would show an increase in your weight temporarily. If the scale shows kilograms, it would show your apparent mass being bigger than your true mass. Now, this is the one we really saw in the video, going down. What would happen if the elevator started to accelerate down? You would feel the elevator drop out underneath you. If it really dropped out, it would feel like being on space shot at the galaxy land as it's falling. You would feel weightless. You feel this because as the elevator accelerates down away from you, it is not pushing up against you as hard as it was before. Since the floor is not pushing up as hard against you, you're not pushing as hard against the floor or against the scale, as they said. A scale would show your weight being less. If the scale showed kilograms, it would show your apparent mass being smaller than your true mass. Let's look at how we'd actually figure this out from a question. So this is probably one of the more difficult questions we're going to do, and you will see something like this on an exam. Okay, keep the following in the back of your mind. A regular scale that you buy in a regular store measures things in kilograms, and it's built for Earth's regular gravity of 9.8, or we're going to use 9.81. Okay. You're standing on a scale in an elevator. You have a mass of 75. Determine what a scale would show if the elevator accelerated upwards at 3 meters per second. So there's three things we're going to look at this formula. F net is all the forces added together, and we have Fg, the force of gravity pulling the person down, Fn, the force of the scale on the floor pushing up against the person. We know from Unit 1, F net is equal to mass times acceleration. Fg is mg plus whatever the normal force is. The normal force is equal to that reading on the scale. Okay, so that's kind of the key. This is the scale. What's pushing up is going to be equal and opposite to what's pushing down. Fn, so solving, if we brought this mg over, we get ma minus mg. And what I did is when you see two of the same quantities, you can factor them out. The reason I did that, you don't have to do this step. It just means one less multiplication step. So I take my acceleration upwards at 3 minus my acceleration due to gravity, 9.8, or if we were being really good, we'd put 9.81 because that's what our formula sheet says. We would subtract, we have minus and negative, so that's adding, we get 12.8 meters per second squared. Then we multiply that by the mass, because it's mass times the difference in those accelerations. And we get 960 kilogram meters per second squared, which is the same as a Newton. We make it slightly different if we actually used the formula, or the given on our formula sheet. So it does change. Sometimes we use textbooks that use 9.8. I just want you to be aware of that. We didn't ask for apparent mass, not the weight. This is the weight. So to find the apparent mass, we need to find this mass here. Okay? The scale we're using has no idea what's going on. It's calibrated to be sitting in a bathroom where gravity is a nice constant 9.8 or 9.81 meters per second squared. So now we have to solve Fn equals mg. And what we're going to do, because we want to solve for m, we're going to have to divide both sides by g. If you do this, I'd like you to do 9.81. And be sure to pause so you can write things down. So the apparent mass is 98 kilograms. Now what if we accelerated downwards? Okay, again, F net equals Fg plus Fn. F net is ma, Fg is mg. plus the normal force. We're solving for that normal force, so we're going to have to subtract mg from both sides, factoring out m, and then putting in our values. Notice we did -4 right here. The reason we did -4 is because the question said it was downwards. Okay, so we do that calculation and 435. Just know if you do 9.81, you'll get slightly different. Now to find the apparent mass, Fn equals mg, divide both sides by g, and again, you'll probably want to do for 9.81, so you should get a slightly different answer here in your notes. Okay, now you have some copied, some homework questions. Do notice that the answers are italicized here. So for part A, the answer is 1.3 times 10 to the 2, or 130 newtons downwards. Okay, and then the weight is 115 newtons downwards. So those answers are given to you right there. I'd like you to try these questions, make sure you know how to use your calculator, and be sure to send me any questions that you have.